Online guys, am I audible to you?
Yes, sir.
Okay, offline guys. Let's start the class.
Yes.
We'll go to class. Okay. Interview, we'll keep it next time. So, it's not that take it easy. I will ask tomorrow. Okay. So, same topics. Prepare well and come. If you miss the class tomorrow, then every day you will have interviews. Every day. Okay. So, tomorrow topics are what? STP, Ether channel, port security, interval and routing, and redundancy protocols. 5 topics. So, go prepare well. Tomorrow, 100% I will ask question. For each person, 1 questions. Okay. I will see who are the persons in online also. Ahmed, Manoj, Devidas, Mohammed Parviz, Ravi Verma, Satish. You also remember, okay? See, these are the guys. Okay? So tomorrow we'll have interview. So today, so yesterday what topic we have been discussing? Redundancy protocols. So in redundancy protocol, so yesterday we have seen all the theories, correct? So today we'll see the practical. So here I'm having a router. Okay. 2 routers. They're connected like this. What discussion? After class. So it is connected like this. R1, R2, this is switch 1, PC1 and PC2. Okay. Like this it is connected. The default gateway, I'm going to give the virtual IP that we have discussed yesterday. So there are 2 routers, correct? So one router has been chosen as active router, other router as standby router. New HSRP. Okay. So which router it is going to select? There must be some criteria, right? Simply one router cannot be active. There should be a criteria that this router should be active, this router should be in standby. Okay. So write down in HSRP active standby election criteria. First one is highest priority, router. That is by default, it is 100 priority. And second one is highest IP address. Write down. Written, everyone. Okay. So I'm having a topology like this. Okay. So here I will say IP ten dot one dot one dot one. Okay. Okay. And as of now, I leave the default gateway. Go to desktop and configure 1.1.1.2. Okay. Now set. Now go to this router. What is the IP? 10.1.1.1. 10 I will give. Okay. .1.1.20 I'll give. Done. Okay. Now go to that interface which are already in. Okay. One command that is standby IP. Okay. Standby 1 IP 10.1.1.100 I'm giving. Okay. Only one command. I'll go to this and say interface gig 0/0 standby 1 IP 10.1.1.1. Okay. And go to this. IP configuration. In the default gateway, I'm giving 10.1.1.1. Likewise, in this PC, I'm giving 10.1.1.1. Done. Now, see, the HSRP state has come up. So what is it in standby mode? Can you see? Because this is the highest IP. Correct. So that's why this is in active. This is .20. This is .10. That's why this is in active. Okay. Now what I'll do, I'll go to this router. I will say interface gig 0/0. Let's make it shut down. Okay, I made it shut down. So now what it will happen? Wait for the pop-up message. See, this router has become active and this router has become shut down. That means it is in standby mode. See, because it is status is shut down. Now again, I'll make it up. Now it has become active. Only one command we are going. Standby 1. But for me, for example, if this router should be the active router for me, I don't want this 20.20 to be the active router. I always want this router. So here you can give, say, see, if you give show standby, you can see it is in group 1. Okay. And status, active router. Okay. What is the virtual IP address I've assigned? That you can give a virtual MAC address, you can see. Okay. And local MAC address, everything you can see here. And what is the hello second timer here? See how this two routers know that it went down. So I made it shut down, right? Other router has become active. How they came to know about it? That this router went down? Through the hello seconds. Hello packet. They will keep exchanging hello packet for every 3 seconds. So if the hello packet doesn't come for 3 seconds, it will go to hold on time. It will wait for 10 seconds. Okay. And if the hello packet does not come for another 10 seconds, then the other router will become active. How they are communicating? Through multicast address 224.0.0.2. That is HSRP version 1. 224.0.0.102. That is HSRP version 2. I'll give it in the PPT. Okay. So that thing is there. Through that, they are coming to know that, okay, this has been, does not give me a yellow packet. So it has went down. So I'll become active. Okay. That's how they're communicating. See, what is the priority? 100. Active router is the local. This router is the local. Okay. And what is this preemption? I will tell you. So now this router is the active router. This router is standby router. I want this router to be always active. Okay. For example, I'm saying I'm making this interface down. Okay. Now this router is active. This router 1 went down. So this router has become active. Again, this router came up. So he's become standby. But I don't want that. I want this least IP .10 to be the active router always. Once it goes down, the other router can come up as the active router. But once my initial router, default router comes up, he wants to become the active. Then what I do? Go to the router and say standby interface gig 0/0. Okay. Standby 1 priority, I'll say 110. I've increased the priority and then I'm saying standby 1 preempt. Once you give the preempt command, immediately the router will become active. So what purpose we are using this preemption command is your interview question. So they'll ask you. So if I want a router to be the active router always, okay, but once it goes down again, if it comes back up, that router should be the active router. For that purpose, we are using this preemption command. Okay, though it is the least IP. Once this router, see, for example, now I'll make this interface shut. I made it shut. It become active to init. Correct. Now I'll say no, shut. I'll fast forward some time. See, it went to standby, but again it became to active. So where we are giving this preemption command means whichever router you want to be the active router always, that router only you're going to increase the priority and give that command, not on every router. Which router your default traffic has to be traveled, that router you're giving this preemption command. Okay, now see. See, standby router is 1.20, you can see. That priority is 100. What about this local priority? It is 110. Okay, and you can see preemption is enabled. So all these details you will be able to see here. Okay.
So yesterday learning and listening step will 15 seconds now, so it will take 10 seconds only.
That is STP. You're not preparing them. That is in STP, not in redundancy protocols. Redundancy protocols, we are having only 2 times. What you're asking is listening state, learning state, forwarding state, correct? Blocking state. That we learn in spanning tree protocol, day before yesterday class. Okay. 1 wicket gone in interview already. Okay. Write down the command. Excuse me. Are everybody doing practicals or not? How many of you did yesterday's practical? See, if you raise your hands, how many of you haven't done it? Be honest, otherwise I'll ask the comments. Raise. Up tall. Vishal? No. Ronnie, no. No. Practical, no. No. You? No. Very good. I have nothing to say. Why you didn't do? You only. You are studying what? So can I ask questions on STP? Huh? Yes. Ready? Okay. Explain the timers. That's it. Write down. See, you are the one you came and asked me yesterday that I want to finish the course early, right? You don't put the hard work away. Only 2 hours class you're having. Are you working now currently? No. So you have all the time to prepare. And you're not doing practicals. What about you? Why you didn't do? Now I know your parents also. I can tell them. Now Dinesh will explain me the timers of STP. Tell me, Dinesh. Dinesh? STP timers.
Hello timer is 2 seconds
Mhm.
and storing timer of big video data to 12 seconds and forwarding data delay forwarding timer is 20 seconds.
Very, very wrong answer.
Yes, yes. Next.
You want to answer? I will ask different question, not same question. Write down. Simply sitting in the class and finishing the course, completing every course, no use. No use. Why, Uday, you didn't come to class? How long?
Long.
Long. Why you did not attend online?
So the festival is
Festival is, you can't sit for 2 hours and study. You did not inform me also that you're,
connectivity is also some village.
how about Instagram connectivity? Girlfriends. See,
No.
Hmm.
Signal.
Connectivity, girlfriend is not there or network is not there.
Signals are
Signal. Signal with girlfriend is not there or network is not there. That's why don't miss class, no. See, you completely miss switching. Switching is over already. Correct. Completely you miss switching. Now, how you will understand CCNP switching? Correct. See, everybody you guys here are paid a fees, correct? Nothing comes for free. So put that hard work for that. Okay. Okay, now we are going to learn translations. See, there is nothing wrong in having signal with girlfriend. That is fine. But sometimes have signal with networking also. Okay. That is what I meant. Okay, Uday? Okay. So you are having girlfriend now. So translations. We are having static NAT. We are having dynamic NAT. And we are having PAT. So what is the static NAT? See, why we need require translation first of all? Tell me, why we require translation? One by one.
To convert the private IP into public IP.
Why we need to come? convert private IP to public IP. For?
network security.
For security purpose? No.
Community other network.
No.
That should not say on private.
No. Why we are doing translations, why we are doing private to public is because to access the internet. To access the internet, simple. If you want to go outside the network and access internet, then you require public IP. So your ISPs will not understand your private IP. That is the reason we are doing the translations. To hide our internal identity also. Okay. First important things is to access the internet. See, here I'm having a router. Here I'm having my ISP router. Okay. Connected with switch devices. Okay. Here it is what IP? Private. Here it is public. So this router will do the translations. Okay. All right. What is this static NAT? That means Himanshu, tell me class B private IP range.
72.16.00.
Okay. Till. What is the range? Aware of it or not? Not. You tell me. Private IP range of class B.
3.9.
There is no might be. Private IP range of class B. You're not sure. You? No. You? You sir. No. Tell me.
172.15.00 to 172.31.255.25.
Wrong. Dinesh will answer.
170.16.002 172.31.255.2.
255 dot?
255.
Why you said 15 wrong? You don't know, you don't know, you don't know. Himanshu, not able to tell. See what is happening? Why are you guys not preparing? Private IP range, your CCNA is over in 34 days. Is my teaching bad or you are not studying? Oh, tell me no. Huh? You are not studying. Nothing from my side. See, we are having private IP range, that is in class A. What is the range? 10.02 255. Class B 172.16.2 class C
Class B 255.
sorry 255.24. Okay, this is your private IP range which I already given you in your notes. Okay. All right. Now, how does your static NAT works? See, I'm having a private IP. For example, I'm having 5 PCs. Okay. This side, from my source, I'm having 5 PCs. So IPs are, for example, I'm taking class C. Okay. Okay. Likewise, 5 IPs are there, 5 private IPs. If they want to use this internet, so they will be translated to public IP. That means this 10.1 will be translated to 1.1.1.1. And 10.2 will be translated to 1.2. Fine. So each private IP will be translated to one individual public IP. Okay. And that same IP will be retranslated to public to private. That is your static NAT. Okay, what is dynamic NAT? So in dynamic NAT, I'm going to create a pool of IPs. Okay. For example, here I'm having 4 IPs. But how many IPs are there here? 5. See, there is no fixed IP in your dynamic NAT. In your static NAT, if I say 10.1, that will definitely be going to be translated to 1.1. 10.4 will be definitely translated to 1.4. But in dynamic NAT, 10.1 will be translated to whichever IP is free in that pool. For example, 10.1 is trying to translate for the first time, trying to use the internet. So he will be translated to 1.1. And next, 10.5 is trying to use the internet. He will use 1.2. 10.3 is there, he will use 1.3. 10.2 is there, he will use 10.4. Now, 10.4 is trying to reach the internet. Is there any IPs in the pool? No. In that case, what will happen? He will not be able to use the internet because all the IPs in the pool are exhausted. If this person try to disconnect the internet, then this IP will become free, then this 10.4 can use 10.1. So there is no any fixed IPs for dynamic NAT. So depends upon the pool, it will be taken the IP. Okay, that is your dynamic NAT. Okay. What is PAT? That is, for all these 5 private IPs, I'm going to use only one public IP, 1.1.1.1. But how they are going to be segregated, how they are going to be identified? Through port number. PAT means port address translation. NAT means network address translation. So these will have different port numbers. Random port numbers will be allocated and they'll be able to use the internet. So in real time, we are not using this static NAT or dynamic NAT because, for example, if in our organization I'm having 1,000 PCs, is it possible for me to buy public IPs? No. Public IPs has to be bought. That is not possible. So that's why they will buy one public IP and through the different ports, they will be able to access the internet. Okay. Now I'm going to give you some theories. You can write it down. Any doubt on this explanation, guys? Okay, write down for static NAT. Manual mapping. Manual mapping. For static NAT, write down manual mapping a private IP to public IP. Manual mapping private IP to public IP. Next point. The number of public IP required is equal to. Next point. The number of public IP required is equal to the number of hosts want to use internet. The number of public IP required is equal to number of hosts want to use internet. Okay. So next point, write down used for system. It is used for system that accept incoming traffic. It is used for system that accept incoming traffic. It is used for system that accept incoming traffic. Okay. For example, server. So in server sites, they are using this static NAT because I don't want this IP to be translated every time. So I want to know exactly which IP is using my server. In that case, they are using this static NAT and server side, not on the routers or PC side. Okay. And write down for dynamic NAT. For dynamic NAT, first point. Here, mapping is done automatically. In static NAT, what I'm doing, I'm exactly telling this IP, this IP. Whereas in dynamic NAT, it is done automatically. Whichever IP is the free, it will use that pool. Okay. So the number of, mapping is done automatically. Next point, a pool of public IP address is used. A pool of public IP address is used. Written. So the private network will be, next point, the private network will be mapped with a private network will be mapped with a pool of public network. Written. The private network will be mapped with the pool of public network. Next point. One private address will be mapped. One private IP address will be mapped with one public IP address. One private IP address will be mapped with the one public IP address. Next point. If there is no free IP in the pool, if there is no free IP in the pool, then the packets will be dropped. Then the packets will be dropped. Written. Everyone, write down for PAT, port address translation. Multiple private IP address. Multiple private IP address. Multiple private IP address are mapped to a single public IP address. Multiple private IP addresses are mapped to a single public IP address. Written. Next point, mapping is done automatically. Mapping is done automatically. Next point, traffic is segregated. Traffic is segregated based on port number. Excuse me. Written. Traffic is segregated based on port number. Now I'll show you the practicals of static NAT, dynamic NAT, and PAT. Okay. So how many networks I have here?
Three networks.
Who said 4? Who said 5? This is one network, this is another network, and this is another network. So 3 networks. Okay. So this is my private IP address. I'm going to give 192.168.10.1, 10.0/24. Here I'm going to give 10.1.1.0/24, which is what range? Private range. Here I'm going to give 1.1.1.0. Okay. Here IP will be 1.1.1.100 I'm giving. Okay. Everything on this router is .1. Okay. Or say .10. So this will be dot 1. Here also dot 1. Here dot 2. Okay. Now I'll go and assign the IPs on respective devices. So this PC. What is the IP? 10.1.1.1. What is the default gateway? 10. Okay. One 192.168.10.1. 192.168.10.10. Dot 10.2. 10 dot. Okay. Close this. Into this PC. What is the IP? 1.1.1.100. 1.1.1.10 will be the gateway. Okay. So we have assigned IPs on all the PCs. Now I'll go and do it on the router. Interface gig 0/0. IP address is what for 0/0? Correct. Say no. Shut down. Interface gig 0/0 0/1. 10.1.1.10. Interface gig 0/2. 1.1.1.10. No. Shut down. Will it ping from this PC to PC5 or not? That means this is my server, or I'll say my ISP. This is my LAN 1. LAN 1. This is my LAN 2. This is also my LAN 2. I have one LAN and two LAN networks I have. This is one LAN network. This is another LAN network. Okay. And this is my private IP. Will it ping from this LAN 2 to ISP or not? Yes or no?
Yes.
Yes. Why?
Oh, there are two different networks.
Two different networks. How will they ping? Different network, I need routing, right?
But when the devices are connected to one router, then no need for routing.
If the routers are connected directly, it will ping. Should say it is connected directly. Okay, locally connected. Okay. Now, what packet is generated now? ICMP packet. Click on this packet. What is the source IP? 10.1. Destination IP is 100. Into this router. Check the IP here. 10.1. 1.1.1.100, correct? Wait. I will do the static routing first. Sorry, static NAT. So here you can see source IP is 10.1 and destination IP is 1.100, correct? So private IP and public IP type request is 8. Done. Now send the packet to router. Go check on this router. What is the source IP now? Same, it is 10.1.1.1 and 1.100 is the destination and the type is 8 only. Now, this is the packet which came earlier. He is going to send it. Now 1.100 has become source IP and 10.1 has become destination IP. And what is the message type you see here? 0 means reply. So the packet has come here. Click on the packet. Same thing. Now the packet has reached. So this is your normal thing. That means there is no translation happened. Correct? So how it is going to do the translation? So that is what we are going to do. Static NAT. Okay. So the reason I show the packet is you want to see the difference before the translation, after the translation. How your router is going to behave. How it is translating the IP address, I want to show you. Okay. Show translations. Is there any? Show IP. IP NAT translations. Is there any translation? No. So I'm going to do the translation. First of all, this is my what network? Inside network. This is my outside network. So I'm saying interface gig 0/1. Okay. IP NAT inside. Okay. Interface gig 0/2. IP NAT outside. Okay. First give this command. Then IP NAT inside source static. First I'm saying IP NAT source static. What is my source IP? 10.1.1.1. Correct. And that has to be translated to some. I'm going to give a random IP. So I'm saying the IP is 1.1.1.50. Okay. First I'm saying IP NAT inside in my source static. Change this IP to this IP. Enter. Okay. Now see, do show IP NAT translations. Can you see? 1.1.1.50. It is going to be translated to 10.1.1.1. Sorry, 10.1 is going to translate it to 1.50. Now see, packet is generated. Source IP 10.1, destination IP 1.100. Packet has come here. Click on the packet. Now, what is the source IP here? 1.1.1.50, which is public or private? Public. Okay, so the router has translated the public IP to private IP. Now see, it will send the packet. Click on the packet. So this is the packet which came earlier, inbound. So outbound, this is the packet is going to reply. Source IP has become 1.100. What is the destination IP? 1.50. He is going to send the packet to 1.50 only. He doesn't know who is 10.1.1.1. Okay. Sending the packet. Click on the packet. Now he has translated to what? Public to private again. He has retranslated it. Do you see any 1.50 here? No. This is the packet which came earlier. 1.50. Now it is 10.2. Okay. Now he will send the packet back to the PC. Okay. This is how a static NAT is done. Any doubt on this? See, we got the reply. Understood? Okay. Just write down the comments. Everybody written? Yes. Okay. Online guys written? Online guys written? Okay. So this is your static NAT. Now see the do show translations. So it is translated to 1.50. Now I'm going to show you dynamic NAT. For this too, dynamically it is going to choose. For that, first we have to going to create the pool. So IP NAT, before that I will say interface gig 0/0 IP NAT inside, because that is the local network. Okay. And then I'm saying IP NAT pool So what is the pool name? I'm just saying CCNA. Okay. And then I'm going to give a start IP address. That is 1.1.1.75, I will say, to 1.1.1.80. 5 IPs I'm going to say. And then I'm going to give netmask 255.255.255.0. Okay. I've created the pool now. So after creating the pool, I have to allow the network. I have to allow one particular network. For that, I'm using access list. Access list 1 permit. Okay. What is the network? You can either say network or host or single host, anything. So here, what is the network that we have to allow? 192.168. What is it? 10.0. So we are using the wildcard bits. Like in your HSRP WASP, we used, right? Wildcard bits, just the opposite of your subnet mask. So It is 0.0.0.255. Enter. First, I've created the pool of IP. After that, I'm creating the access list to allow the network that has to be translated. And now I'm going to apply it. Okay, that is IP NAT inside source list 1. What is the pool name? CCNA. Enter. Okay, done this. I'll go to this PC. Packet is generated. Click on the packet. Source IP is 10.2, 192. Destination 1.100. What is the IP now? 1.1.1.75. Because I've created the pool from 75 only. That's why it has taken us 75. Click on this packet. He is sending to back to 75. Send it back. Now click on this packet. He would have retranslated to private. See, 192.168.10.2 is there. That means public to private. So this, while coming, it has sent it to 1.75 only. But the router has retranslated to our private IP. Okay, and then we will receive the packet. Understood? Now I'll try to ping from this IP. What IP will this be translated to? 10.1 is there, private IP. Now let's see. One dot 76. So between that pool, it is going to take the IP. Okay. Likewise, it will go and it will come back. If we click, this is the packet which came from the router ISP for 176 and it is retranslated to 10.1. Okay. And you will receive the packet. Okay. So this is your what? Dynamic NAT. There is no fixed IP. Randomly, it is taking the IP. Okay. Any doubt on dynamic NAT? Sure. And say do show IP NAT translation. See, 10.2 is translated to 75. 10.1 is translated to 76. That you can see in your translation tables. Okay. I don't. Next, I'll show you PAT. So what is this port address translation? So multiple privatized IPs will be translated to single public IP. So your basics of CCNA is over, routing is over, switching is also over. Okay, complete switching is over now. So what are the topics left? We have DHCP. One main topic is DHCP and IPv6. These two things are the uh, major topics left. That is over. Then all are small management protocols that we'll discuss accordingly. Okay. Written everyone? Okay. Now what I'll do, I'll take two more PCs. Three cables are there. Okay, I'll just remove these comments, dynamic comments. Or I'll just remove this static net. This is my static net. Okay, I've removed my static net. Now I'll try to ping. Now it is not getting translated because I removed the command. Okay. So what I'll do, okay. So this IP is already given .1. Here I'm going to give .2. 10.1.1.2. Dot 10. Okay. What is not visible? Okay. Now I'm going to do the PAT. That means I'm going to create an access list. Access list to permit. What is the network I have to permit? 10.1.1.0. Correct? 0.0.0.255. Okay. And then IP NAT inside source. Okay. List to source list 2. Okay. Here it's just like your dynamic net. Okay. In dynamic net, what I'm doing, I'm creating a pool and I'm saying this. So here I'm saying translate to this IP only, this interface IP. Either you can give an separate IP or you can just say translate to this particular IP only. So I will say whatever the packets are coming, translated to 1.1.1.10 itself. So I'm giving the outgoing interface. So say interface, okay, gig 0/2. Okay. After that, one command you have to say overload. For PAT, we are saying overload. So keep repeating the same IP. Enter. Done. Now see. Ping 1.1.1.100. Enter. Packet is generated. So 10.1. And so destination IP is 1.100. Packet is here. Now click on this packet. It is translated to 1.1.1.10. Yes. What is 1.10? This IP, gig 0/2 IP. Okay. Packet will be went and come back. Now if you see, it will be retranslated to 10.1.1.1. And the router is going to send it to, that means this ISP is going to send it to 1.1.1.10 only. He is not going to understand who is that private IP. Okay. And again, I'll click go and it will come here. Okay. This is one. Other one, go to simulation, go to this PC and say ping 1.1.1.100. Ten dot 1.1.2 destination IP is 1.100. What is the source IP here also? Same IP. That is 1.1.1.10 only. It means what? Every network, I mean every IP which is going to be used in that 10.1.1.0 network will be taking the translated IP as 1.1.1.10. So multiple IPs we are using, we are able to translate it to one public IP. So that is your port address translation. Okay. Any doubt on this? Okay, write down the command. Only writing command, not doing any practicals. Correct. What's really?
Yes.
See, I have to lie to your dad that you're doing very good. Is he strict? That's why.
Yeah.
That's why you're not doing practical. You're from Bangalore only.
Sir.
North, yeah, you told me, right? Yes, yes. Your parents are staying here in Bangalore?
Most of the days came from sisters.
Oh, okay. You're staying in PG. Written. So, what we have discussed today? HSRP practicals, we have seen what is static NAT, dynamic NAT, and PAT. So 4 practicals we have seen, correct? All right. So we'll wind up today here. Okay. So tomorrow we are going to learn DHCP. DHCP theory, practicals of DHCP, DHCP relay agent, and then DHCP snooping. All those topics we'll see tomorrow. Okay. Online guys, any doubt? Online guys? No. All right. So I'll end the meeting here. Rest we'll discuss tomorrow. Thank you.